Perhaps the simplest way of doing relation extraction is using hand-built patterns. Let's look at the intuition. Here's a sentence. Agar is a substance prepared from a mixture of red algae, such as gelidium, for laboratory or industrial use. Perhaps you, like me, I didn't know what the word gelidium meant, but I can learn what it means from this sentence. And the way we know is that we see this phrase, red algae such as gelidium. So that tells us that gelidium is a kind of red algae. And this intuition from an early paper by Marty Hurst suggested that there's in fact a lot of patterns that can be used to suggest that two entities are in this ISA or hyponym relation. So for example, knowing if I saw red algae such as gelidium, that tells us that gelidium is a kind of red algae. So X is a kind of Y. I might see other patterns like gelidium or other red algae, or gelidium and other red algae, or red algae including gelidium. In each case, I have a textual pattern holding between two entities. That's a strong cue that what I have here is a particular relation between the two entities. And Hurst showed that these kind of patterns were able to learn the ISA relation between new terms such as Bambarandang and Bolut, or learning about author names or learning country names and so on that could be added to a database. Now, the same kind of intuition about using handwritten rules to learn relations can be used for the richer relations that we've been looking at, richer than just ISA or hyponym. And the intuition for learning these more richer rules is that these relations often hold between specific entities. So the location located in relation often holds between an organization and a location, or the founded relation holds between a person and an organization. So in addition to just coming up with clever string patterns that might indicate a relation, we can also use facts about the actual entities that are involved, and that will help us learn which kind of relations we might have. In other words, we're going to start with named entity tags, and that's going to help us do relation extraction. Now, named entities aren't quite enough, and to see this, let's look at a couple of examples. Imagine I have an entity drug and an entity disease. What kind of relations can hold between those entities? Well, a lot. The drug could cure a disease, it could prevent a disease, it could even cause a disease. And that's true for any kinds of entities. Between a person and an organization, the person could be the founder of the organization, they could be an investor in the organization, a member of the organization, an employee of the organization, they could be the president of the organization. So any kind of relation may hold between these entities, although there are constraints. So the person can't be the cure or the disease cause or other kinds of things. So there are constraints from the named entities, but lots of other relations meet those constraints. And so we're going to combine these two intuitions using a pattern and using the named entities. So we can combine these two intuitions, use of a named entity and use of specific patterns, to extract richer relations. Consider the question, who holds what office in what organization? So we'd like to extract from a sentence like George Marshall, Secretary of State of the United States, that a person, George Marshall, played the role or had the office of Secretary of State in an organization, the United States government. And so we have an entity person, an entity position, and an entity organization. And here's a pattern, person, comma, position of organization, that might extract from a sentence like this the position of relation between a person and an organization. And we might need to have another pattern for sentences of a different form. So here we have person, Truman appointed Marshall Secretary of State. So we might have person appointed, or some other word like named or chose and so on. Person, position, and we might have an optional preposition in between. So Truman appointed Marshall as Secretary of State would be an option there, or just Truman appointed Marshall Secretary of State. So again, a combination of our patterns with maybe lists of possible words that we might get from a thesaurus or some kind of thing, and the named entities of the entities. Or finally, another pattern, George Marshall was named U.S. Secretary of State. So again, person, and maybe a form of the verb to be, and optionally followed by, again, one of these named or appointed words, and then maybe an optional preposition, and then the organization and the position. So by combining the named entity types with the words or perhaps parts of speech in between, we can create patterns that extract particular relations. Now, an advantage of the pattern extraction algorithm for doing relation extraction is that these human patterns tend to be high precision. If you look at a particular domain and you write rules, and the rules are usually pretty high precision, and they can be tailored to these very specific domains. If you have a particular relation extraction task, when you write rules, they can get this high precision. The minuses are that human patterns tend to be low recall. Often, you don't think of a particular way somebody might have thought to word a certain sentence in free text that expresses a relation. And it's also a lot of work to do this, especially if you have a lot of relations. You're going to have to come up with very specific patterns for each relation and for each domain in this relation. And it'd be nice to also get a higher accuracy than you can get from these relations. So while hand-built patterns are a useful method for relation extraction, we're going to look at other methods like supervised and unsupervised methods as well. So handwritten rules with named entity patterns and other kinds of words and parts of speech in between are a good way to extract relations. They have some problems of accuracy and of generalizing to new domains. And so we're going to also introduce other methods of doing relation extraction like supervised and unsupervised learning.